Okay, here we are. Welcome, welcome, everybody. My name is Jordan. Welcome to the very first episode of Living Soil Mastery. We're live. We're live on YouTube, and a good hello to everybody out there. I'm so stoked to have you join me today. It's going to be the start of a really cool series. Something that I'm really obsessed with is living soil biology. And getting to understand our soil better is something that a lot of us are just probably lacking or missing out on in today's world, in today's gardening world. And I think that something like this was really up my alley. It was something that I really wanted to bring to you guys and to everyone. So if you are watching live, a couple of housekeeping things. There will be a chat function underneath. So if you can, see the chat function, please let me know that you're here. Say your name, where you're from, or something like that. Or if you have a question or anything that's coming up during the stream, if something I said triggers a question for you, then please feel free to drop it down in the comment section or in the chat below, because even though, this video will be up for eternity afterwards, I will be able to get to a lot of those questions and then maybe answer them in future live streams. If there is a question that comes up today that I can answer for you that is in alignment with what we're talking about today, I will definitely answer it. But if I can't, like I said, I'll go into the comments section afterwards and give you my best thoughts on that topic. So, look, a little bit about the Living Soil Mastery course. It's been an idea for a little while in terms of just brewing up what I wanted to do with this and how I wanted to present it. But I just thought that doing it on my channel, doing it live, and interacting with a lot of you guys would be my favorite way to do it. So throughout this series, we're going to be diving into an absolute ton of topics to do with living soil. And it's not lost on me that soil is very much underappreciated. It's often the first thing we think about is normally the plants. Someone says, what are you growing at the moment? And it's not necessarily thought about the soil too much. We're all thinking about, okay, what plant is it? How much sunlight has it got? How much watering do we need? And companion plants and all of this kind of thing. But we're overlooking the soil itself. So this whole series is about understanding and really getting to grips with what soil is, or what we should be thinking about soil. Hopefully changing your perspective, having a little bit of a different view on what soil is and what that means, and then being able to give you some practical advice, some practical examples, and some things that you can take away with you to improve your soil at home. This first episode, we have to cover the basics. We have to cover the foundations. And that doesn't mean that basics is basic. It means that we have a lot of fundamentals that need to be understood, more so from a perspective point of view, less than a knowledge point of view, but really to just overview kind of what we're thinking about in terms of soil in this whole series and as living soil. And then we'll go down all of the different rabbit holes of the different topics as we go along. So I'm so excited to have you with us. If there's any problems with the stream, please let me know in the comments as well. But otherwise, we're going to kick this off because I don't want to fluff around too much. I want to get straight into the content. So yeah, let's do it. Let's jump in. If you can see the PowerPoint off to the right, we're going to just jump in and put this up. Here we go. So with living soil, if you understand, hang on, I've put myself on here. There we go. Let's go back to the share screen. There we go. Wrong button to start with. If you understand these concepts, all right, if you're understanding everything else in the garden makes more sense. And I really want to guarantee you that understanding this concept, the foundations, how all of these moving parts work, is crucial to understanding how our plants and our, everything else works as well. Because literally our health, if we backtrack from even our planetary health, if we backtrack from all of our health, it all starts with the soil, all right? We are what we eat is quite a commonly heard thing. We are what we eat. Hello. Hey, Carolyn. Thank you. Nice to have you. Thank you so much for joining in. Thanks for dropping a comment. Yeah, our health, if we work it back, what we eat the plants or even the animals that then eat the plants or eat the grass is grown in the soil. And there's an extremely high correlation between our microbiome and the microbiome of the soil. So there is a lot of similarities that we will obviously explore later in depth. But I really want you to understand the concept that we are part of nature. We are part of this living, breathing organism that we all are a part of. And the soil is no different. So we really want to understand this, and I promise you everything else will start to make sense in the garden. So let's jump in a little bit further. Let's go to the next slide. I've done it again. Press the wrong button. Here we go. Let's come through. Okay. I promise I'll get it right from now on. So soil is not a product. All right. It's not something we should be thinking about getting or buying from the garden center or something like that. It's not a product. Okay. It's not a container either. It doesn't mean that it's just something for our plants to be sitting in. That's just not quite the right way of thinking about it. And as I alluded to before, that's often how we think about soil. It's just the thing that you put it in. And as Carolyn points out, she wants to stop buying crappy potting mix. And this is exactly it. So we're going to be talking about how to recognize what good soil actually is, and then, understanding that some of the potting mixes, some of the composts and things that we do go out there and buy have strict sterilization and all of these things that are happening to them, which means there's no life in these soils. Soil is a relationship, as you can see up on the screen. And what that means is that it's got all of these moving parts. It's very similar to us as human beings in a way that we have all of these, individual organs or pathways and connections and messages and signals being sent around the body, all to create this whole person, this whole ecosystem of human being, of us in the end. That's the exact same with the soil. The soil is a relationship between many, many different things, between life in the soil, between water, between electrical currents, between the aggregates and the types of things like sand and clay and all of this that we're finding in our soil. So we'll dive into all of this in depth again further down the track. But I want you to understand that it's a relationship. It's not just this dead, soulless thing that we have. So what does make soil actually living? Well, there's a few parts to it. And as I said, there are moving parts and they are all interacting. As you can see here, we have biology, minerals, air, water, roots. All right. That's just to be really broad in terms of categories. We've got so many other things within those categories that we'll talk about, but these things are all interacting within the soil to do the role of providing for this full ecosystem and giving us the whole. So the sum of all the parts is giving us the whole. So that's a really, really important one to first grasp, that this living component involves all of these different parts. So if we have all of these different parts, we need to understand about the way that food goes through the system. Something that we all think about is fertilizer. We've got to feed our plants, right? We've got to throw some sort of food at our plants in order for them to grow up and eat something. A lot of people understand, just like our pets, we need to look after our plants and give them some food, give them some water and things like that. So plants don't actually eat the fertilizer themselves. There is foliar spraying, and that's slightly different. But if we're putting fertilizer into the ground of any kind, the plants aren't actually eating that. What they're doing is they're trading for it. They're trading for the nutrients with the soil life that is down below. So what that means is they're taking carbon and sugars that they draw from the atmosphere, and they're then sending it down into the soil and trading that resource with the life in the soil, which have the nutrients for them. All right, so that's a really important trade concept to really understand. The plant itself is not eating the fertilizer. It's trading for the fertilizer. Just like we might go and buy our food from the shop. It's the same type of thing. So let's have a look at that cycle and what that looks like. First and foremost, the plants are photosynthesizing. One of the most important things as a grower we understand is the plant's ability to photosynthesize, to be able to take in the sunlight and convert it into sugars. Now, the plants do photosynthesize. They then take that, convert the sunlight into energy. This energy is in the form of sugars or carbon compounds, which they then donate 30%, which is a huge proportion of it. Imagine all of that energy that they're using to grow. They're donating 30% of that down through its roots, through these root exudates, which are these, basically, it's what's released from the root. Again, we'll go into more detail, but it's what's released from the root, and that is what is traded or attracts the microbes to then make that trade. The microbes, all right, they mine the nutrients. So they're going down in and around the soil. They're finding deposits of all of these different minerals or compost, organic matter, these types of things, and they are mining those nutrients. Now, once we go into it in a future episode about the different types of soil life and the way that moves, that nutrient moves up through the chain, essentially all we need to know for now is that the nutrients are released once those microbes that had first consumed them, they're released once they've been eaten. So it's kind of a bit of a food chain that we're working up from that original mineral. So once those minerals have been spat out, and might I add, they are in now a plant available form. You imagine a piece of rock or rock dust in the soil, deep in the soil. The microbe is going and mining that mineral. The plant root itself can't just tap into a piece of rock and draw the minerals out of it. There's a process of it being broken down first and turned into a plant available form, which then our roots take up in the rhizosphere, which is the area in and around the root, and then it's taken up into the plant to be used. So this is such a symbiotic relationship between all of these different things about cycling these nutrients, trading for resources, all of these types of things, something that we're very familiar with as human beings. Now, something that Dr. Elaine Ingham, if you haven't heard of her, she's somebody who you should certainly look up. Dr. Elaine talks about this concept called the soil food web. And now it's become widely accepted and widely understood that the soil food web is something of vital importance and something that we need to keep intact. This comes into the concept of tilling our soil, digging up our soil and turning it in on itself. What we're doing is we're going in and we're slicing and dicing all of the networks, the communication, all of the life that's going on in that soil. We're slicing that up as if, and in a lot of my talks, I say it's like someone's come and sliced all the internet and phone lines every season, and we're having to try and, send letters to communicate and figure out how we're doing all of these different things. So it's very inconvenient for the soil, and it really doesn't help that soil food web. But what do we mean by the soil food web? How does that relate to these nutrients going into the plants? Well, life is feeding life is feeding life, and that's how I mentioned it before. We have these steps of the way these nutrients are taken to the plant through various different microorganisms. The first four categories, the four categories that we're going to be talking about in terms of these soil food web stars, we've got builders, transporters, recyclers, and regulators of these nutrients. So the builders, they're what I would consider, our miners. They're going in, they're getting in there, and they're putting nutrients into themselves after mining it out of something. Really basic concept for now, because we don't want to go too hard. Transporters are then moving that mineral somewhere else in the soil where it may be needed or where it can trade or something of that nature. Recyclers. Recyclers are recycling exactly what it says, the nutrient, for reuse elsewhere, or it may be recycling organic matter or something like this. And then we have regulators, and regulators are sort of like the overviewers, the managers of the whole thing, making sure that everything kind of goes to its right place, or there's not too much of this, too much of that. An overseeing manager of sorts. All right? So 4 categories, really simple, and that's kind of the basis of where we want to start with the soil food web. Now, nutrients aren't added into the soil in a perfect system. They are actually recycled. So if we imagine a tree, okay, it's grown up, it's got all of its leaves, all of the canopy layer up on top. Eventually, a lot of that organic matter is going to drop down to the soil, and it forms this mulch layer on top of the soil, this forest floor, I like to call it. And that is organic matter, right? It's been through that cycle of carbon where it's become a tree that's then falling to the ground, It's sitting on the ground and it starts to decompose. But it doesn't just turn into nothing. It gets turned into plant available nutrients via the soil food web. So this is kind of how that cycle starts. All right, it's dropping organic matter and bird droppings, insects, all of these different things dropping onto that mulch layer, and then they are being turned into plant available nutrients by the soil life, which is then taken up by the tree and used to create more leaves, more organic matter, and the cycle continues. So this is a really important idea, is that it's the same with energy. Energy is never sort of ends. It's always transmuted or transpired. I'm not quite sure of the right word, but it's always transformed maybe into a different kind of energy, a different use elsewhere. So soil doesn't actually die without fertilizer. It's something that a lot of people sort of go, oh, my plant, it's not able to, sorry, I didn't feed my plant, so it's dying, or I didn't water my plant, or something like that. And that's not actually the case often. It's the connection. It's this breakdown of all of those elements that we went through before with the roots and the air and the water and the microbes and all of this. It's that breakdown of that living system. Imagine our heart stop communicating with our brain. That's a very simple and easy way to understand that the connection severing is what causes the problem. It's not necessarily the fact that the heart could be working really fine and you go, but my heart's working and my brain's working. Why is the whole body not working? And it's because there's that connection that's disappeared. We see this in a lot of neurological disorders and things and illnesses, when there's a connection that's missing, a link that's gone. And even though a lot of these individual parts may be working well, the connection is gone, so we lose the whole, which in soil is very, very important. So that's another important concept to understand. Let's move on. Talking about carbon. Carbon is energy. All right. If nutrients aren't the driver, then what is? If nutrients aren't the ones that we're feeding directly to our plants, what actually is it that our plants are using? And it's the carbon, it's the energy. All right. Carbon is in this carbon cycle. It is the energy that transmutes, or I've said it again. The energy goes through all of these different points, through into the tree, into the ground again, and into the microbes, and each part is using that carbon as energy and making that trade. So every living thing in the soil requires this energy, and carbon is that energy. So going back to this concept that we were talking about before, the plants are pulling carbon out of the air, carbon dioxide. We know this. Trees breathe in carbon dioxide and they breathe out oxygen. It's an incredible thing that nature is providing us with what we need and we provide it with what it needs. Funny that, isn't it? So they take the carbon out of the air using sunlight. Okay, interesting concept. Very, very kind of funny, difficult area to understand. But once I can explain it to you, I think you'll understand a little bit better. But they turn it into sugar. And then, as we mentioned earlier, they're deliberately sending 30% or roughly or thereabouts down into the roots for the microbes below. And that is how the soil life is fed. It's every single day. This is happening daily. And, if you don't have a sunny day, your plants can't photosynthesize as well. If that hangs on for quite a few days, that we get these storms, this cloud cover, and we lose the light, it impacts everything in the garden. It's energy from the sun that powers absolutely everything. I believe we're very much similar ourselves as human beings, solar-powered entities, just like the plants, just like all of the animals, needing that sunlight for all the parts to be working effectively. So structure in the soil now is something that we're going to be moving into, but I want you to understand that structure itself is better or greater than fertility in this instance. So if we're thinking about our soil structure, we're talking about something that it's like, what is it made of? What is it composed of? Is it mostly sand? Is it mostly clay? And these two different extremes can provide very different results for whatever is growing in it. Now, you can have a packed out, nutrient-filled soil with nutrients galore, compost galore, all of this kind of thing. But if the actual structure of what you're growing your soil in is not there, then it's all out the window. Life needs oxygen before nutrients. Oxygen is the absolute backbone of everything that is happening here. Same with us. How long do we survive without oxygen? Very similar with the soil. I told you all of these concepts really relate. They mirror between us and the soil very, very nicely. So oxygen is vital in all of these important mechanisms. Now, oxygen getting into the soil is not something that we think about. We don't think about the soil breathing, having this exchange of gas between the carbon dioxide and the oxygen. This is something that we really miss out on. So remembering, soil needs to breathe. So we need to have this happy medium of breathing, and then moisture, and then nutrients, and you'll find this nice balance. So what does good structure actually look like? What do we mean by good structure? And you can see in the picture there, actually, that this picture I've chosen has a relatively nice looking structure. We'd have to maybe have a feel, and I've got a couple of examples that I can show you in a second of good structure that I have taken myself. But we're going to go through a couple of points here as to what might be identifying points of good structure in our soil. So if you pick up your soil and it's crumbly, what I mean by crumbly is it's got this crumb-like structure. And you can see in the picture, it kind of has all these little crumbs. It's not giant chunks, and it's not one matted clay ball, for example. You can see these little tiny sort of crumbles as if you'd like crumbled up pieces of, apple crumble or whatever. It's very, very simple to understand once you can see it quite often. But crumbly is something that we're looking for. Smells earthy. You don't want a putrid smelling soil. That's often quite a bad sign. It means that it's anaerobic, and anaerobic means lack of or without oxygen. So we don't want that. We want something that smells earthy, and generally that means that it has enough oxygen exchange capacity or carbon exchange capacity. So smells earthy. You need to smell it and you go, that smells like nice soil. You don't want it to smell terrible. It's a very simple one. You want it to be alive. And what do we mean by alive? Because we're talking about living soil, but you want to see things moving in it. Often worms are quite a really good example of seeing life in there, and it's probably one of the most obvious things that we do see in our soils these days. So worms is a really good example of being alive. You can see these little tiny mites, or soil mites, or you might see these little fungus gnats or composting gnats or something on the top of the surface. But most importantly, that's not a bad thing. A lot of people freak out. I mean, especially if it's inside and you've got all of these creepy crawlies moving around. People freak out. And I can understand that. If you've got it in your kitchen and you've got fungus gnats flying around everywhere, it can be a little bit off-putting. But for the most part, we want to understand that soil is alive, and you want to see moving things in that soil. The next one is good water management. Now, Phil Dudman, actually, shout out Phil Dudman, lovely gentleman, showed us on his Instagram recently what good draining soil actually is. When you pump the hose on your soil, what happens? Does it disappear rapidly? Does it run away as quickly as you've put it in? Does it go straight out the bottom of the pot and run off down the hill? Or does it sit on top for a while? Does it sit there and just pool up on top of the soil for a while and barely drain at all? Or what we ideally want is for when we put that water on there to just casually be just sinking into that soil and just draining away but not pouring out the bottom of the pot. That means that there's good water management. That means that it's able to hold water, wick water throughout the whole system, throughout the whole pot. And then also it's, you're not just flushing nutrients out, and also it's able to penetrate the soil too. So really good water management, and that comes with the structure of the crumbliness, that comes with, having decent amounts of organic matter and things like that in it. So it's kind of crucial to have good water management, especially in this heat. Now, I've got a couple of examples for you from my Instagram. I'm really hoping the audio works for these. So this one in particular is at my parents' place, just digging under some plants. But you'll be able to see what the structure is and what it looks like. If you can't hear it, obviously it's got captions, so you can read it as well. But let's have a listen and see what the good structure looks like in terms of real soil. And this is in the ground, not in a pot or anything. When we're looking at the quality of our... Okay, hopefully that's working. I don't think this is working, the audio, but anyway, you can still read it. See how it's just sits together, and then when you push it, it just falls apart? It's exactly what we want. Perfect. So I'm sorry that the audio didn't work. That's probably my bad. I need to kind of try and figure out how to fix that. But at least you could see what happened when I squeezed it together. It held together in this nice ball. And what that means is that it's got enough holding capacity that I could squeeze it together in a ball and pass it to you. And then you might take that, and then you can just lightly press with your thumb and it crumbles back apart into those smaller crumb-like aggregates. That's just the most perfect that you can have it. It means that it's the right amount of moisture, it's the right amount of organic matter, and all of the above that we saw spoken about in this video. Now, the next one, this is in a raised bed here at my place. And this is a very new raised bed, so it's only a year and a half, 2 years old in terms of soil. We've used a lot of these living soil strategies to try and get it good. Get it good, that's not a very good English, but, you know, get it looking good. And in this, I think I'm planting corn. So let's have a little look and see what the soil looks like. It comes at the end of this. You get this bonus seed treatment tip. We will be going into mycorrhizal fungi later on, obviously. Easy seed treatment. Someone reminded me that they're not seeds, they're kernels, but anyway. So let's have a look at the soil. So under the mulch, see, again, holding together, pushing apart. And you can see those crumbed aggregates right there. So that's what I mean by structure. And you can see the crumbs. It looks like crumbly soil. Like that's essentially what it is. And when you water it, you can see that it just comes through nicely, just drains slowly through and evenly as well. It's not running off in different river directions, trying to go down different holes. It goes through the whole thing nice and evenly. Now, talking about water, okay, because water is just so crucial, okay, again, similar to us, we need water as well. The planet needs water, and plants and soil need water. But water is not just moisture. A lot of people just think you need a drink. You know, it's just something that we hydrate ourselves with. But in this case, in the soil, water is a messenger. Now, thinking about water as a messenger may be a strange concept, but let me explain. So water carries information. It carries nutrients. It carries oxygen in small amounts. And it also carries signals from various different things. Okay, again, I want to try and keep this nice and broad, just more conceptual today. So the water carries the information, and it's speaking or allowing the connection and the speaking between a lot of different things in the soil. Now, if water can't move properly, nutrients stall, oxygen disappears, biology slows, and the roots in the plants suffer. And what I mean by move properly is that same thing through the structure, the wicking, where sometimes you can just sit a pot in a thing of water and you'll find that the water wicks up through the bottom of the pot and saturates that soil nice and evenly. That's generally a really good sign of good structure. The water means that the nutrients stall. Okay, a lot of the nutrients can be carried around by water, and a lot of the organisms in the soil require water to be able to transport or break down these nutrients and things like this. It means that the biology slows down because there is this lack of water in the soil, and then everything suffers because of it, because soil is the foundation. Again, credit back to the name of this episode. The soil is literally the ground level, the foundation of everything, in this instance at least. So what does too much water look like? Well, too much water means that the nutrients stalled, the oxygen disappears, the biology slows, and the roots in the plants suffer as well, because we're waterlogging, all right? The oxygen is, it's supposed to be in the soil, and it's supposed to be able to breathe. We can't breathe underwater, right? So if we're underwater, there is no oxygen. It's the same as the plant roots and all of this type of thing. Everything's going to suffer if it's drowning in water. So there's this nice balance that we need to be able to come to in terms of that. Roots can't breathe underwater. They breathe air. All right? Again, we breathe air too. Roots breathe air. And we don't think about the soil breathing. We don't think about that. The air is actually located in the spaces between those soil particles. So if you don't have any space in between those soil particles, what happens? There's no oxygen in that soil, so there's nothing for the roots to breathe. They're drowning, it goes anaerobic, and then everything suffers. All right? There is a pretty, different swing if you've got something like clay soil, which I have, which is very dense, very anaerobic in a lot of ways. There is not much oxygen that's able to come in and out of the soil. But then there's also sand, where if you're on an island or something, or if you're close to the beach, sand is going to be the majority of your soil. And when water goes into sand, what happens? Bang! Straight, all the way through. It can flush nutrients out, it can flush everything out, and there's nothing to hold on to that water. So, yes, it can breathe. Yeah, it's very breathable. But also, there's no water in there. So then we're lacking that water, and again, nutrients stall, oxygen disappears, blah, blah, blah. We have the same result. Okay? Let's move on. Roots. We're talking about plant roots now. We talked about roots earlier as part of the system. The plant roots are building soil. And that's an interesting thing. They're building the structure of the soil as well. You imagine roots. As the roots grow, they actually open pathways. They feed the microbes and leave tunnels behind. So we spoke about this before, how they're donating 30% of their sugars down into the root zone where they can feed the microbes. They're opening these pathways. They're pushing their way through the soil. And then, as you saw before with the corn seed video, corn kernel video, we were using mycorrhizal fungi. It's a type of fungi that attaches to the root, and it extends that root system up to 10 times, I think, from memory, out into the soil to be able to collect resources. So not only is the root going out and creating this tunnel and pathway, but it's connecting again with other roots through this mycorrhizal network, massive part of the soil food web. So they're pushing through the soil, they're connecting with the fungi, they're feeding the microbes, and we're building structure, all right? We'll go into how some of the specific organisms are building structure, like mycorrhizal fungi is really good at creating some of that crumb structure, bringing together a couple of aggregates of smaller parts of soil to make bigger ones so that we've got more room for that oxygen and drainage and all of that sort of thing as well. All right, time to talk about diversity. Diversity is the core principle of nature. if you had to boil down what it is that nature is trying to do, it's trying to diversify. It's trying to bring in as much diversity as it can into a certain situation. Now, diversity comes in, a lot of different forms when we look at it. We might be diversity of insects, diversity of wildlife, diversity of plants, and then microbes and all of this type of thing. But if we think about the concept of as above, so below, we can see that diversity above ground represents diversity below ground. So this is why, I have a product of a cover crop blend, which is a 15 seed different cover crop blend. Now those 15 different seeds are different species for different reasons. They're attracting different life in the soil to be able to do the jobs that they particularly require and increasing that diversity. So different plants release different carbon compounds. That's what we were talking about with those root exudates into the soil. They attract different microbes to those exudates, to those compounds, because they're it's different food for different people. And they're building different pore sizes as well. So these things are all happening as part of the diversity that's going on in the soil. And this diversity above ground that we can plant is going to generate, or it's going to encourage, a lot of diversity below ground. And if we understand that diversity is the core principle, it is the backbone of what nature is trying to do, then we can help it out. We can actually help by putting in some diversity. And this comes down to resilience as well, because it builds resilience. If you imagine diversity of income, for example, in human beings, if we've got a lot of different income streams, and then all of a sudden one of them gets shut down, we're actually okay. But if you've got all your eggs in one basket and then it can totally disappears, then you're a little bit hung out to dry, aren't you? So resilience comes from having options. We can build a good structure, but diversity decides how strong and adaptable that structure becomes. So having all of these different things in the soil means that if one particular part of it is suffering or wipes out, then we've got all of this backup, all of this community help. It's like if someone gets really down and out in the community, everybody rallies around them and helps them out. So diversity builds resilience, a really important concept. Now let's talk about some of the soil progression. Okay, so soil, as you can see in the picture behind it, is very desolate in that particular instance. But soil needs living roots to survive. What happens if we leave bare soil lying around? What happens? Nature throws something down on top of it, doesn't it? It throws down, most likely, weeds and grasses. We've all seen that. You've left a bare patch for a while, or there's no mulch on this section, and then all of a sudden you've got tons of weeds. Weeds is a totally different story, but weeds are so important. Let's just go, what happens when we leave bare soil? So if we leave the bare soil, like we said, sorry, I skipped forward there, weeds. Here we go. So we can see in the background, we have some weeds that have appeared in the soil, okay? So it used to be this desolate landscape, and now we've seen a few of these pioneer weeds coming in. Speaking about weeds really briefly in this instance, we're talking about the fact that certain weeds come up at certain times for certain reasons. They're a messenger, all right? We might have a weed that comes in that has a really deep taproot. That's this nice thick root that goes down into the soil. What might that be doing? What function is that serving? Well, it's breaking apart the compacted soil. So often you'll see these weeds appearing in compacted soils. It's allowing the water to penetrate a little bit deeper into the soil, down that root system. Okay, if we see something that has a really interconnected root system, nutgrass is the one that we often see. Terrible one. Again, really good for breaking up compaction. It's often found in compacting soils, but what it's also doing is a bit of structure. It's got this network, or you see these sort of creeping weeds that come over the things like bindweed and stuff, where they're doing exactly that. They're binding, they're holding, they're trying to create some sort of structure, bring in organic matter and capture it and try and keep it in that space. So it's really important to kind of change our view of weeds for something that's really bad to thinking, okay, these can actually be really good. They're a signpost of what we might need. What do we then next see if we left this bare soil? All right, we see grasses. Grasses are coming up. We can see the grasses in this. They're often moved by birds. They might be dormant in the soil. The grass is starting to come up and they're starting to cover the soil, essentially. It becomes a grassland. Now, this whole concept that we're talking about is progression. It's natural progression. We have this big swing in nature between grassland or empty open plains all the way through to dense, heavy rainforests and forests. Well, not necessarily just rainforests, but forests in all sorts of different situations. So nature is moving a certain way. And it doesn't just get to a forest and like if we just left the entire world, the whole thing would turn into a forest. No, that's not actually what's happening. It's oscillating. It means it's moving backwards and forwards between these two states over such vast distances and times that we can't even comprehend. But if we observe, we know where it's heading and we can start to do a few things that might help it along its way or guide it into the right place that we might want it. So grasses is what appears next. Then what do we see? We see shrubs. You can see in the picture in the background again, we've gone a little bit further. Some shrubs have started to appear. We've got some smaller bushes. We've got some things providing a little bit more shade now. That's cooling down. There's not as much soil that you can see. So we're not losing evaporation, some water and all that sort of thing. We're trapping things in the soil. The root system is starting to really break apart and build that structure. The shrubs are coming in. We're moving closer to a woodland, which is next. I mean, you can call these what you like, and they're all sort of slightly different depending on where you are, but that's a beautiful woodland, which I really like. It's got some flowers in there and things as well, so that looks really good. And then we're moving into, finally, like I said, a forest. Okay, so something that's a lot more dense. We've got some really big trees. There's different layers of canopy and all of this kind of thing. So you can see that we're progressing towards this forest and then back again and between the two. But we don't need to grow a forest in our garden, do we? We can borrow from it instead. We can borrow from the technique. We can understand where it is, where it's trying to head, and we can actually go along with it, swimming alongside downstream rather than upstream against it. Really simple concept. It's just observation. And observation is power in the garden. Observation is power in nature. Sit in your garden. I highly encourage you to just go there and sit and watch. And do this regularly throughout the year when it's pouring down with rain, when it's lashing down and you can see all the water moving all over the property, when it's completely bone dry and it's, so hot outside. Early mornings, late evenings, even in the middle of the night, set up a camera, observe what's going on, and then you'll have an idea of where it's moving, how it's behaving, and then how you can best slot in to help that. So some techniques. All right, we're going to be talking about some of these techniques, definitely in more detail as we go along in this series. But these are some of the techniques that we will be covering in terms of building soil health, and things like this. Look at that picture behind it of that healthy pasture with different plants in there. Diversity everywhere. That's what we're talking about. The first one is cover crops. I mentioned that before with the 15 seed cover crop blend that I have for sale. This one is really important for building that diversity. You're basically planting diversity and then you're encouraging diversity under the soil. So that's a really, really big one. Chop and drop. All right, this is using the plant's own organic matter and dropping it down to then have that process of the forest floor where it gets broken down, turned into plant available nutrients, and then used again. So we can pick specific plants for this. We can just literally go through and just chop branches and leaves off, or let nature do its own natural chop and drop that it does tend to do. Compost. Everyone knows compost. We're going to be diving into compost and why, because as we mentioned earlier and as Carolyn highlighted in the chat, that she's looking for better potting mix. And this goes for the same with compost. They're all sterilized in the large largely produced versions of this. They're sterilized to meet standards, and that means that all of the life, all of the microbes in the living things in there are just gone and desolate. So you're not actually adding any life into our soil. So then we need to be focusing on what good compost is and how we can build that, where we can source it. So compost, we're going to be diving into for sure. Fermentation, a really important one as well, because as we're beginning to understand with our gut, fermented foods are super important, or just really good for us in general. And again, this mirrors in the soil. So we have ferments. I've done a few beautiful episodes with two lovely gentlemen talking about ferments on the podcast, which you can go and check out as well. So fermentation or ferments are a really good addition, and we're going to be talking about those too. Mulching. Mulching is just such a simple way to help your soil. But there are some nuances, and there are some things that you need to consider when talking about mulching, because different types of mulches, different ways of doing it, and all of this kind of thing. I think it's really important to cover that. We're going to be talking about no-till. I brushed on this earlier about slicing and dicing those networks and breaking apart that soil food web. No-till means to not dig, or no-dig gardens. Or minimal till is probably where I'm sitting at the moment, like a very, very minimal till. There are instances where, like if you're just starting out and there is no life in the soil, there's no structure, it's completely hardened off or whatever, you might need to go and turn that over and add some stuff in and settle it up to begin with. But then after that, you can leave it. So that's no-till. We're going to be touching on that as well. But ultimately, living soil is about direction, not perfection. It's a simple little motto to be thinking about. It's about moving in the right direction, but not thinking about doing everything absolutely perfectly. The good thing about a healthy living soil, especially if it's in an abundant amount, if we've got a large garden bed or if we've got a large pot, it's often very difficult for the biology to keep up with the plant when it's in a very, very small pot. So a larger soil amount, a larger battery of soil, a larger buffet of all of these nutrients and living things is actually going to, mitigate any problems that you might have. So it's about trying to go in the right direction, not trying to be absolutely perfect about every detail. There are other growing methods, hydroponics, where, for instance, where you have to be a little bit more onto the ball with what you're feeding, because it's directly going in via the water, and it's very, it's very easy to overshoot or undershoot. So living soil, we just have this beautiful ability for it to kind of sort itself out, especially if we're, again, moving in the right direction. All right, where to from here? What does this mean? What does this look like for the next few episodes? Because today we just scratched the surface. We're just talking about the concept of what living soil is and how do we recognize it. But we want to dive down deeper into the rabbit hole. So how are we going to do that? We're going to slow down first and foremost, because we need to. These topics can take hours and hours and hours. This is why it's mastery. 10,000 hours is often quoted as mastering something. And I certainly have done my fair share of hours, but I wouldn't consider myself a master either. But we're all on this quest to try and get better and to try and become a master of this. Also, a master, is like, they have that thing, or they're part of that thing. It's almost an extension of themselves when you master something. And I think that soil is an extension of ourselves. If anybody pretends to know everything about the soil, then, they're probably wrong, because we're always learning new things, and we need to be open to learning new things, and I'm always learning. But this is a culmination of all of this knowledge that I've picked up over the last few years, put together in the most, understandable format that I can do it for you. But we're going to dive deeper. We're going to look at all of these different concepts. I absolutely love going deep on topics, and this is exactly my rabbit hole that I like to go down. And then finally, real techniques. This is practical help. I'm talking about all of these things, like I showed you in that clip earlier about the corn. Using a little technique like that is just an incredible way to start your seeds. It forms this symbiotic relationship, as I mentioned in the video. But we're going to have these real techniques that you can go and take home and apply to your garden. Remember, you can always ask questions as well. You can drop them down in the comments. You can leave me a message or something like that, and I'll be able to help you more specifically to yours. I'd prefer, obviously, if it was public, because we can help more people if they're checking out in the comments below as well. But look, ladies and gentlemen, I've tried my best to do this in a manner that is, understandable and relatively slow to kind of go through these foundations. But that's it from me. So if you want to stick around for the next episode, I don't have a schedule as to when this is going to be. So I highly recommend that you go and click subscribe on the channel, and then it will pop up in your feed and you'll be able to see it. There's also notification bells which you can click, which I've got on a certain few people, where it'll actually send me a notification to say that, hey, Jordan has released a video or Jordan is going live, and you may want to go and jump on and see that. But I am super grateful for your time here, for coming and listening to me for nearly the last hour. This is something that I'm so passionate about, and I can't wait to help as many of you as possible through this whole series. It's going to be going on for a while, so stick around. Thank you so much. I really appreciate you. And yeah, I think we'll finish it up there. So thanks so much for watching, and we'll see you again real soon. Thank you, and bye for now.